In this video, we'll look at how to use a limit of sums to evaluate a definite integral. We'll start with the generic definition. We have limit as in approaches infinity, the sum from I equals 1 to n of f of x sub I delta x. In order to use this, we first need delta x. And the way we get that is the formula b minus a over n. So we have 5 minus 0 over n, or 5 over n. And then x sub I, the formula for that is a plus delta x I. So we have 0 plus delta xi, which is 5n I. So now filling in what we have to the formula, limit as in approaches infinity, sum I equals 1 to n. And now we'll plug in our x sub I to the equation f. We have 1 plus 2 times x sub I, which we found to be 5n I cubed, times delta x, which we found to be 5 over n. In our next step, we can pull the 5 over n out of the sum. And we can simplify the cubed part. That is 5 cubed is 125 times 2 is 250 divided by n cubed times I cubed. Limit as n approaches infinity, 5 over n, sum I equals 1 to n of 1, plus, and in the second sum we can pull the 250 n cubed out of the summation, leaving us with the sum of I cubed. Now we have the limit as n approaches infinity, 5 over n, times the sum of 1 is n plus 250 over n cubed. The sum of I cubed is n times n plus 1 all over 2, and that quantity is squared. From here, we'll simplify that last piece. Limit as n approaches infinity, 5 over n plus, we have 250 times n squared times n plus 1 times n plus 1 all over n cubed times 4. Next, we have the limit as n approaches infinity. From here, let's distribute the 5 over n inside the brackets. So we have 5n over n plus 1250 n squared. Let's go ahead and distribute that binomial. N squared plus 2n plus 1. And all of that is over 4 n to the 4th. At this point, we can reduce a little bit. These n's will reduce n squared will cancel here, and we'll leave that with n squared. 4 goes into 1250, 312.5. Now we have the limit as n approaches infinity of 5 plus, we need to distribute 312.5 inside the parentheses. So we have 312.5 n squared over n squared plus 625 n over n squared plus 312.5 over n squared. Again, we can do some reducing here. At this point, we can start to evaluate the limit. We get 5 plus 312.5. The third fraction will go away to 0 because we have n in the denominator. The fourth fraction will also go to 0 because n is in the denominator. So this leaves us with 317.5.